Hello everyone, I'm going to talk about a problem in chapter 6, which is regularized approximation problems. And this problem is a basic of bi-criterion formulation problems, and its goal is to find the minimum of the vector x. We should need this x to be as small as possible, and meanwhile we should also make the residues of a x minus b, and we should make this part as small as possible. So as a result, this objective function can be written like this. We should minimize both these two parts, and we can assume a variable which is lambda, and lambda is from 0 to infinity. So as a result, this part can be rewritten into a function which is and our purpose is to minimize this function, and we should pay attention that if this norm is a Euclid norm, and we can know that both these two parts are greater or equal to 0. So as a result, we minimize this part. It is the same questions to minimize this part. These two questions are equivalent, so we can see that we can change these questions into a standard convex optimization, and we can know that these parts are we can calculate by this. So as a result, we can arrive at this step. This is lambda, and okay. In order to if this convex optimization problem has no other subjection, so we can transfer this convex optimization problem into this part, and if we want to find the optimal value, we should make the derived form of this function to be 0, so we can work out the x and the x star, and the x star is the optimal point of this function, and we can figure out the optimal point by optimum value by replace the x with x stars. So the x star is equals to x star is equals to it satisfies this function, so we can figure out the optimal value of this point. So after we figure out how to deal with regularized approximation problems, we can applied it into into application which is we consider a signal which is x. We use x to represent a signal, and we consider that this signal is influenced by a noise, a white noise or other kind of noise is okay, and we can say that the noise, we use V to represent the noise, and so that the signal after the influence with noise is this one. So what can we do to get rid of the noise? So we can get rid of the noise, and so we can we want to make this part as small as possible, because as small as possible, and meanwhile the signal we can know that is any signal, and it doesn't change too fast. And if we use MATLAB to simulate a signal, and we can know that it doesn't change too fast, we can see that we can arrive at this equation, so that it can change to the optimization problem mentioned above, which is we want to make this part as small as possible, and meanwhile we want to make this part as small as possible. So this denoise questions is transferring to a regularized approximation, which is and we need this part equals to phi x. So we can see that we can transfer this problem to a standard convex optimization, and there are some subjects, and the subjects maybe is related about the power of the noise, or the power of the original signal. And these are the subjects, and we can use what we learned in chapter 5 to deal with this convex optimization problems. So that's what I talk about today.